So today we're going to talk about indexing. Now, an index in a database, this applies to any kind of database that you have, but specifically today we're going to talk about Microsoft Access Database. Indexes are an important thing to use in your databases. Think of them like a card catalog. It is a way for the program to already know where some of these things are so that it can line them correctly when it runs your query. So I have here a database. These are all the same, pretty much the same tables with about 500,000 records in each, and I've joined multiple tables into one query. So in these ones that say they are that do not say index at the end, if we design the table and we look at it, it's got an ID number that is unique, and then it says no to the indexing. So these are not indexed. So when I run the query join ID, if we take a look at this, these are the four tables, and they're joined with the ID field. You will see that it does take a little bit to come up, so it took a couple of seconds, and down the bottom here, it took about 7 seconds until this 529 showed up down at the bottom. This shows us the number of records. Once that's actually complete, then the query is fully ran. So while it's showing you data right at the start after a couple seconds, it still takes a little longer for it to come up. So if you were using this on a form, it would take longer for it to show because it would have to show all the data before it could display. So that took about 7 seconds. Now, I've done something here that, obviously is not suggested, but I just wanted to show it. This is to do a join on a non-numeric field. So this is a name field, so this is somebody's name. You would obviously never do this in real life. Names are not unique. People have the same names, and this would not be a good thing. And you can see in here that we don't have this index as well. So what I'm going to do is I'm going to run this, and you'll see that this takes quite a bit longer to come up. So this is why using like an ID field in your database is very useful. So it's displayed, and then it took about 11 seconds total before the 529,000 came up. So these are all unique names, so it actually is showing the exact same number, but it is possible that names are repeated. So it, again, is not a good idea to do a join on something like a name field. It takes a lot longer, and then you could have duplicate records, so you don't want that. Now, I have now indexed these fields. So this is the same table, exact same data, except for the ID field and the name just for fun. We've indexed. So I've indexed this, and you can see it says index no duplicates on the ID field because the ID field is unique. Every single table has the same numeric numbers, and they are unique. They don't repeat. In the name field, I put that as duplicates okay to allow duplicates. So it's going to be different than the ID field. So now, if we run this now, what we will see is that this will come up. So it's running now, and this came up in about the same amount of time. So this is a good show. So this looks like nothing has helped. But what we're going to do, actually, let's run the name one first. So we're going to run the name one with an index as well, and we're going to see how long that takes to come up. So this one is running, and it looks like it actually took a little bit faster than the other one. But what we're going to do is once you create an index, it's always good to compact and repair your database. This allows a database to rebuild the indexes that you've placed in. So what I did with this is I copied those tables that didn't have an index, and all I did was add an index. So I didn't re-import the data and allow the index to create. So now when we run this query, so if we look at the query ID index, so if we now run this named index, so this is the query that will use the name, this ran a lot faster. So this ran in about 3/4 of the amount of time that the one without the index ran. And if I was to run the one with the join ID, so this is where it's joined by ID, and I was to run that, this one has run in a few seconds faster as well. So not an incredible amount of time savings. This is pretty simple data, 529,000 records. And this is just purely on the query. Like I said, if we were then to add a form on top of this, or we were to add some other kind of data, like if we were exporting this or we were putting this to a record set, it would take even longer. The main one without the index and then the one with the index as well, but then your numbers would be significantly different. So we can see there's definitely a time difference with the indexing of these fields. And like I said, if you were to use a query without index fields, and then you were to at first it may run fine, right? So that is something that always trips people up, is they create a query and they run it. So let's do this join ID right now. So this is running. It's up to about 8 seconds. So this about 11 seconds that just took. And it's like, okay, that's not that bad. Somebody goes into the form and they'll have to load. But once you put this into a form, it's going to take even longer. Once you start scrolling through it in a form, it's going to take longer. You want to export this to an Excel sheet, it's going to take even longer. So it's important that even though the query, the indexing doesn't look like it made a huge amount of time, definitely made a time improvement. Like I said, the name one was very significant amount. It was almost half the amount of time. On the IDs, one thing to remember is this is raw data that we've just put in. As you change this data and you move this data, so if I was to try and move this data around, so say I was, I can't copy that many rows. If I was to insert new records, do something like that, there would be a significant amount of time that this would take. So one thing to remember is data as it's changed will make a difference in the queries running, especially on non-index fields. So this has managed to run fairly quickly because the data is just pretty much raw data. But as the data's changed, you insert new records, remove records. I just did a few there, and you see if you time it, it did take another second or two longer. But if you were to do a significant amount of changes to these tables by inserting and deleting a lot of records, editing records, there would be the amount of time that this join would take, that this query would take on the non-index fields would be significantly more. Because what happens is, again, on our simple data where this is pretty much, you got 47,169, but if you sort this by numeric value, this is just 1 to 529,000. This is very simple. We've just imported it. There's nothing else in the table, in the database. But if we were to keep editing this on the index, it would continuously recatalog that data so that it would be always fresh. On the other one, it wouldn't. So it would become more and more weighted down and more difficult to run. So that would continue to slow down. So indexes are very important. They're very underutilized in databases. A lot of people look at them. Like I said, we've got fairly simple tables here, but somebody looks at this and says, you're doing 500K between four tables, and it's running 11 seconds. That's not bad at all. And it's not the worst, but it will progressively get worse and worse. But by adding those indexes, the slowdown, it will still slow down a little bit, but the slowdown that it will take those queries to run will be less and less, and you'll lose less and less time on those. Thank you for watching. Please don't forget to like, subscribe, and comment. Please also share. Please go ahead and check out my other videos on my page. Have a great day.